The intermediate user logon allows the operator to work either in the quick editor or the text editor. It also allows for a quick new program with more options than the basic user logon simple pick and place program that is created in the quick new generator. To enter the quick new program interview, the operator can either select the quick new create tab or go to the file tab, select new, and under the quick new wizard, select the create tab. This opens up to a program sequence page that allows the operator to include certain functions in the program to be generated, such as a reject or a QC. If those functionalities are not required in the program, a simple no answer will eliminate any further questions in the interview process pertaining to that functionality. Maneuvering in the interview page, you can use the slider to move up and down the page. You will also see that you have an animation and hints associated to each interview question. If these are not required, you can simply remove them by selecting the details up arrow, and only the question and its answers will appear. If you want the animation and the hints to appear in the interview question, select the down arrow for details and the animation and hints will reappear. So on the program sequence page, the questions to be asked is first, what is to be handled by the end of arm tool? We can select runner only, we can select parts only, or we can select both runner and parts. Next, does this program require a reject routine? By selecting the appropriate radio button, a yes answer will have further interview questions for the programming structure required to include the reject routine. A no answer will remove any further interview questions for the reject. The same pertains to the QC, whether this program will require a QC drop or not, answering with the appropriate radio button selection. Eco mode option is also included in the program sequence. It is recommended that eco mode be used as much as possible in as many programs to save wear and tear on the robot. Once the program sequence has been selected, you can go to the next interview page based on your answers from the program sequence. We select the next tab. Since a runner sequence was included in the program, we now have to answer how the runner shall be held. It can be held either by vacuum, gripper, or vacuum and gripper. In our example, we'll select gripper. And since we are selecting a gripper, it now wants to know which gripper number from the configured grippers on the robot should be the handling group for the runner holding. Select configure, select the gripper options from the drop-down. All available grippers will appear. Select the gripper number to be included and inserted into the handling group. If more than one gripper is required, you include that gripper number also and insert it into the handling group. Close out this page and continue with the interview process. Since we said that we were holding the runner with grippers, we now have to answer the question, is gripper sensing or gripper monitoring required in the program? If there are no sensors on your grippers, then a no answer or a selection of the no radio button. If gripper monitoring is required, select the Yes radio button. The activation of when to close on the runner can either be before ejection or after ejection. Simply select the correct radio button to include when the gripper should be closed on, when the gripper should close on the runner. And the runner handling release answer can be selected as before the pot is placed, after the pot is placed, or at the same location with the pot placing. In our example, we'll select before pot placing. Once the runner holding page has been completed in the interview, you want to select the next tab to continue with the interview process. The placing sequence type is asking whether we should do a standard place program, meaning that you can have up to 16 different placing locations that will place the parts sequentially from 1 through 16. Or we can do a bulk fill. A bulk fill allows a container to be completely filled prior to moving to the next container. So you can have the number of containers. If the bulk fill is selected, you enter the number of containers. We will have an additional video explaining the bulk fill options. In this video, we will stay with the standard selection, and we will say that we have 2 placing positions, meaning that the end of arm tool will take 2 parts, place part 1 in location 1, and then move to the second location and drop the second part prior to going back to the mold to get the next 2 parts. So a standard placing program will allow you to place up to 16 different placing locations sequentially before returning to the mold for the next set of parts. You can choose how the parts are going to be held on the end of arm tool. They can be either vacuum only, gripper only, or vacuum and gripper. In this case, we'll select vacuum. If vacuum is selected, then we have to answer the question whether we want to monitor for vacuum when the part is received in the mold and retain monitoring throughout the placing location, and then turn off monitoring. If no monitoring is required, select the no. If monitoring is required, and it's highly recommended that it is, select yes. We also have the option whether to palletize at an individual position, selecting individually. So placing position 1 can have a palletizing program, and maybe placing position 2 does not. Or we can say, yes, we want to have a palletizing program at all placing locations, or no palletizing program is required. In our instance, we'll say no palletizing is required. Once the general placing questions have been answered, select the next tab and proceed to configure for placing position 1 which vacuums, or if you selected grippers, which grippers would be holding the part. We're going to select the Configure tab. Since we had chosen vacuum as the equipment type to hold the part, we can select from all the configured vacuums on the robot which vacuum will be holding the part for placing at location 1. Insert it into the handling group. If more than 1 vacuum is required to hold part 1, select the next vacuum in the list and insert it. Close out this page and then continue with the interview process. The next two questions on this page pertain to whether a conveyor is used and whether the robot should wait for the conveyor to stop moving prior to placing the part. If that is required, select the Yes radio button. If it is not required, select No. The following question is whether the conveyor should index after the parts have been placed at location 1. If this is required, select the Yes radio button or select No. Then you can select the next tab to configure the information for the placing position 2. So once again, for holding parts that are going to be placed at position 2, select the Configure tab to insert the correct vacuums that are holding those parts for position 2. From the drop-down, highlight the vacuum number and insert it into the handling group. Close the page and continue with the same questions previously concerning how the conveyor belt should react. In our case, we will select Yes on both radio buttons. Select the next tab to continue with the interview process, which is pertaining to the reject sequence that we selected on the first interview page when we said, yes, we want to have a reject routine in the program. The reject routine will allow you to set the number of startup rejects whenever the press is started. How many shots do you want the robot to scrap before placing good parts? It will also allow the robot to reject the parts from the machine reject signal. And here it's asking, do you want the reject to be placed at a conveyor location and run the conveyor in the opposite direction, let's say from a good part direction, anytime a reject signal is given? If a conveyor is not being used and we are placing the part into a granulator or a reject bin, then the animation shows the robot releasing parts at a granulator. If you say yes, it will show that the conveyor indexes. It really goes to the conveyor. So this is if you have a reversing conveyor. Select the next tab, and here you can answer the questions required for the program to handle a QC shot. You can select whether the QC shot should be based on a auto switch that allows the operator to press a auto switch on the main screen of the pendant anytime he wants to QC the next good shot, or you can select the QC to be based on a QC count. After so many good parts, a QC shot will be delivered to a QC location. If you select both, then you have the option to QC a part at any time from the auto switch, or if that is not done, then every certain number of shots will be QC'd by the count. If neither of you are required, select no to both. If only one is required, select one and leave the other as no. Select the next tab. In here we have the option of doing a traditional takeout, which requires the robot to wait above the mold for mold fully open before entering the mold to remove parts. Smart removal is the optimized removal function, allowing the robot to enter the mold and combine the movement of the X and the Y axes as efficiently as possible to enter, retrieve the part, and exit the mold at a faster cycle time. In some cases, traditional is required. Select the radio button for traditional. in most cases, smart removal should be used to optimize the removal process. You will also have the ability to choose a safe wait location to wait outside of the mold area in case there are obstructions on the mold, such as cylinders that prevent the robot from entering the mold area until mold is fully open. Please view the video for the safe wait options to be able to utilize that in your program structure. If this is not required, then you can choose between the traditional and smart removal takeout in the interview process currently. The ejector parallel in is to rid the program of signal latency and allow the ejector signal to be given prior to the robot being at the pick position in the mold. If this is required, select the Yes tab. If not, select No. Select Next, and here the operator in the intermediate login is allowed to determine if a core pull sequence is to be used. If this is selected as yes, then the operator can decide whether they're going to include the standard core sequence, which is mold open, core pull, ejector forward, ejector back, core set, and then mold close. If the machine is controlling the core sequence and that sequence is required as a specific core sequence, then you can select the IMM controlled core sequence. The program will give the permission for the cores, and only during the machine sequence will the cores move according to the machine instructions. If no cores are needed, select No, and then select the Next tab. The mold exit allows the operator to also determine whether it should be a traditional exit, meaning that the robot will fully exit the mold prior to mold closing, whereas a smart removal exit allows the robot to efficiently exit the mold, allowing mold to close as the robot reaches the mold safety switch and safely closes behind as the robot continues up out of the mold. The ejector parallel out allows the ejectors to move back while the robot leaves the takeout position. A yes or no answer is required. Part break allows the robot to remove the parts from the mold, breaking it away from the mold at a reduced speed. This will be a relative value when setting it up in the quick editor. It allows the operator to teach a certain distance relative from the pick position to move back that relative distance prior to moving at full speed. Select the Next tab, and here you can create your program. You can enter comments into the program, so in the future when the program is reopened, any comments such as mold open size, ejector stroke, job number, customer number can appear in the program. Select the Create tab, and at this point the quick edit parameters will appear and the teaching of positions, timers, speeds will be allowed.